Well, thank you. So let me, I'm going to, rather than just watching my talking head, I'm going to use a PowerPoint to illustrate the story of the Rocky Mountain locust. So let me jump onto that right away. Here we are. Right. So as Blaine said, I wrote a book a few years ago titled Locust, The Devastating Rise and Mysterious Disappearance of the Insect That Shaped the American Frontier. And it's a story that I think is very important in American history and certainly important in terms of the history of the Western United States, but it's a story that not many people are aware of, at least in any sort of keen sense. So tonight, I want to share with you this very remarkable story. So I'll begin. The tiny, limp body had been violently mangled. Although the corpse had also begun to rot, it still retained distinguishing features and the essence of its original form. Having spent the last 4 years honing my forensic skills while searching for precisely these remains, I was able to identify the body as being that of Metamorphosed spretus, the Rocky Mountain locust, the only locust known to have existed in North America. This was the first incontrovertible specimen of this creature to be collected in nearly 100 years. Its extinction, which culminated in the early days of the 20th century, represented the loss of a continental scale process. No longer would this living conveyor belt distribute immense loads of organic material across the Great Plains. Consider, if you will, that large swarms weighed thousands of tons and required 100,000 pounds of vegetation a day to stoke their metabolic fires. No longer would an eerie shadow sweep across the cloudless prairie and then give way to the papery rattle of billions, even trillions of insects in flight. These events are still known on every other inhabited landmass, but North America will never again experience the staggering scale of life in motion, the humbling sweep of fecundity, or a biological eclipse of the sun. After finding the first small body in the ice of northwestern Wyoming's Knife Point Glacier, my colleagues and I began an excited search for more, eventually recovering 130 largely intact remains. Each was cataloged, dried for preservation, and individually stored for future study. On the last day at the glacier, we set a drift net in one of the hundreds of rivulets that rushed down the face of the ice. In just 24 hours, we collected 140 fragmented remains of the Rocky Mountain locust. At this rate, more than 1 million corpses have melted from the glacier since that day in 1990, washing into Dinwoody Creek and perhaps being carried to the Wind River. The icy grave had served as an effective, if somewhat brutal, final resting place. Based on radiocarbon dating and geological analyses, we surmised that as the pilgrims were arriving at Plymouth, this swarm of Rocky Mountain locusts, originating from the river valleys that would one day become part of Yellowstone National Park, was being swept up the valley and blown onto the glacier. Scattered across the ice in a seething carpet of brown-green bodies, some of the locusts may have managed to escape and continue their journey, but millions were immobilized by the cold. In the course of summer melting, they were washed into the crevasses that split the top of the ice field. With time, they were frozen deep in the glacier and slowly transported down the side of the mountain until they came to a point 750 feet below the crevassed section. Here, the slope flattens abruptly, and the ice, in a slow-motion version of the rapids that form at the base of a waterfall, becomes turbulent, churning its embedded contents to the surface. For the first time in nearly 400 years, the locust emerged into the light. Although the swarm associated with these frozen bodies has long faded from memory, the Rocky Mountain locust is deeply embedded in the lore and culture of the American West. So let's begin the story of the Rocky Mountain locust in the period of the old frontier, an era in which new lands were being explored. From here, we can see how this creature came to shape the nation during a time of pioneers, farmers, miners, and naturalists, a time during which a young country was trying to grasp the promises and perils of its frontier, a time in which the natural world was on a collision course with manifest destiny. This is the story of what happened, a necessary context for understanding what extinction means for humanity. With a voyeuristic eye, we can peek into the lives of the pioneers, reading from letters they sent back to family in the East. In July of 1874, Edwin Snyder of Highland, Kansas, penned a chilling description of a summertime blizzard transforming into a swarm of locusts. He wrote, "At our place, they commenced coming down about 1 o'clock in the afternoon, at first only one at a time, here and there, looking a little like flakes of snow, but acting more like the advanced skirmishers of an advancing army. Soon they commenced coming thicker and faster, and they again were followed by vast columns or bodies looking almost like clouds in the atmosphere. They came rattling and pattering on the houses and against the windows, falling in the fields, on the prairies, and in the waters, everywhere and on everything. By about 4 o'clock in the afternoon, every tree and bush, buildings, fences, fields, roads, and everything except animated beings was completely covered with grasshoppers." While some settlers described their experience in qualitative terms, others tried to quantify the intensity of the insect invasions. After a swarm had departed, one Minnesota farmer went into his fields to see how many eggs had been left behind. Digging into the loose soil, the poor fellow was flabbergasted to find that no matter where he dug, the ground was packed with egg pods. Turning over a shovelful of soil and making a careful count, he found that there were 150 eggs per square inch. Well, perhaps he'd been an accountant before becoming a farmer, because he determined, and I quote him, "At this rate, there will be 940,896,000 eggs to the acre, or a nice little pile of 6,586,272,000 on my 7 acres of farm." Certainly, not all of these eggs yielded locusts, and not all the hatchlings survived the course of development. But if even 1 in 100 reached adulthood, his farm would have produced 60 million locusts, about twice the human population of the country at the time. Now, we might be tempted to dismiss such pioneer tales as the stuff of legend and lore, but the federal government was reluctantly affirming the depth and breadth of the crisis. A U.S. Army major was dispatched to Nebraska in the fall of 1874 to assess the situation. His report to the Secretary of War revealed that in the most desperate precincts, 4 out of every 5 families were at risk of starvation in the coming winter. In the best of circumstances, 1/3 of the people required assistance. Although he was a veteran of the atrocious suffering of the Civil War, this battle-hardened officer was clearly moved by the plight of the settlers. He concluded his report with a plea for immediate action on the part of the government to avert the impending disaster. He wrote, "Great suffering exists in all 5 of these extreme frontier counties to a fearful extent. The settlers are, in most instances, scattered over a large extent of country, a large portion of them living far up the numerous streams flowing into the Republican. If the winter should be as severe as that of 70 and 71, and as deep snows fall, beyond a doubt hundreds will starve unless a supply of provisions sufficient to last them through the winter is thrown into the valley and they are provisioned for an emergency of this character. For it would be out of the question for any aid society, or the government even, to reach anything like a majority of them in deep snows." As temperatures dropped and suffering mounted in early 1875, Congress took up the matter of the pioneers' plight in the bitterly cold days of winter. Lawmakers appropriated $150,000 in food and clothing, quote, "to prevent starvation and suffering to any and all destitute and helpless persons living on the western frontier who have been rendered destitute and helpless by the ravages of grasshoppers," The Dakota, Missouri, and Platte departments of the Army participated in a massive relief effort. 1,957,108 food rations were distributed that winter. According to military records, the recipients amounted to 107,535 people, including nearly 44,000 children in Colorado, Dakota, Iowa, Kansas, Minnesota, and Nebraska. How many graves were filled with emaciated victims of the locust in the winter of 1874-75 is not known, but perhaps hundreds succumbed to hunger. The number would likely have been in the thousands if the country had not rallied to save the starving settlers. The suffering of the pioneers is most powerfully etched into the American mind by the writings of Laura Ingalls Wilder's Little House on the Prairie. In the fourth book of this classic series, locusts devastate the family farm on the banks of Plum Creek, and the father is forced to leave his family behind and search for work. His journey echoes our culture's canonical story of people wandering in the wilderness, seeking the promised land. Laura learns from her mother's reading of scripture that locusts played a pivotal role in the time of the Egyptian pharaohs. And so the tale of the pioneers became interwoven with Western culture's most deep and abiding literary account of locusts. Perhaps the Wilders sensed that they were part of a great human migration, an American exodus across the continent. But what they did not know while watching their farm disappear under a blanket of locusts that summer was that no people on earth, not even a pharaoh, had ever witnessed a swarm of such immensity. Albert Child. Albert Child was a Renaissance man on the frontier. After practicing medicine and serving as a school superintendent in Ohio, he moved to Cedar Creek in Cass County, Nebraska to try his hand at farming. But Albert Child's real passion was not medicine, not education, nor agriculture. Rather, he adored the science of meteorology. And as soon as he arrived in Nebraska in 1857, Dr. Child started keeping weather records. In 1861, he began providing reports to the Smithsonian Institution, and his work was transferred to the U.S. Signal Corps when they took over as the country's weather service in 1873. By then, he'd been elected county judge and moved to Plattsmouth, but his love of meteorology was unabated. This is how Albert Child came to be the right man in the right place at the right time to provide a definitive report of the most immense swarm of locusts in recorded history. He began his account with the objective tone of a trained and experienced observer. He wrote, "The extent of the swarm is difficult to ascertain, as the observer can only see a small belt. They may extend indefinitely right or left. During the flight from June 15 to 25 of 1875, I telegraphed east and west. I found a continuous line moving northward of 110 miles, and then somewhat broken 40 miles farther. The movement of the winds for the 5 days, the 15th to the 20th, averaged about 10 miles per hour, and the locust evidently moved considerably faster than the wind, at least 15 miles per hour. To determine the height of the swarm, he used a rather clever approach. Dr. Child focused his telescope on various objects of similar size to a locust, placed at known distances across the rolling hills. Then he'd aim the instrument into the sky, and if the locusts were in focus, he could conclude that the swarm must be at least as high as the horizontal focal distance that he had just determined. The method yielded only coarse approximations, so Dr. Child was cautious in his estimates. But in reporting these observations, his awe at the scale of the phenomenon began to sneak into his technical report. He wrote, "The swarm I estimated from 1/4 to 1/2 mile deep. It seemed like piercing the Milky Way of the heavens. My glass found no limits to them. They must have been a mile or more in depth." Like any good scientist, Dr. Child took his data and transformed the raw numbers into a complete picture of what he had witnessed. The mathematics were simple, but the results were nearly beyond imagination. When Dr. Child presented his straightforward calculations as to the aggregate size of the locust swarm that was passing over Nebraska, he was incredulous of his own findings. He wrote, "They were visible from 6 to 7 hours of each of the successive 5 days, and I can see no reason to suppose that their flight was checked during the whole 5 days. If so, the army in the line of advance would be 120 hours by 15 miles per hour, or 1,800 miles in length, and say even 110 miles in width, an area of 198,000 square miles, and then from 1/4 to 1/2 mile deep. This is utterly incredible. Yet how can we put it aside? An area of 198,000 square miles would encompass the combined areas of Connecticut, Delaware, Maine, Maryland, Massachusetts, New Hampshire, New Jersey, New York, Pennsylvania, Rhode Island, and Vermont. The swarm was probably an elongated stream of insects, but if it had been configured in a more familiar geometric shape, it would have comprised a square 450 miles on a side. The frontier of the New World was revealing marvels and terrors of a scale unparalleled in written history. The largest swarm of locusts outside of North America was reported in 1954, when less than 100 square miles were covered by the notorious desert locust in Kenya. No insect outbreak has ever approached the magnitude of the Rocky Mountain locust. Trying to estimate the number of locusts in what might be called the perfect swarm is quite a challenge, but we can use some values from the scientific literature to approximate the size of the population. We might safely assume a settled density similar to that of the famed locust swarms in Africa. If so, then the 1875 swarm that passed over North America had 3.5 trillion locusts, outnumbering the current population of the current human population on Earth by a factor of 600 to 1. The swarm outweighed a man to the same degree that the biomass of a whale exceeds that of a mouse. Such quantities are unfathomable, but newspaper stories of damage from across the West clearly substantiate Dr. Child's observations. If we find it difficult to imagine such a mass of life, it is even more challenging to grasp that less than 30 years after Dr. Child's account, the Rocky Mountain locust disappeared forever. At first, the disappearance of the locust was simply unbelievable, but an enticing explanation soon emerged. A locust is a special kind of grasshopper, not a particular taxonomic group. The locust has a peculiar life history strategy, a sort of Dr. Jekyll to Mr. Hyde transmogrification that involves the capacity to change its physiology, behavior, and morphology in response to environmental cues, especially crowding. The gregarious or migratory phase is darker in color, has longer wings, and exhibits a propensity for aggregation, which accounts for its forming into dense bands of nymphs that then develop into vast swarms of adults. In the solitary phase, the locust is indistinguishable from a grasshopper. So different are these phases that for decades, entomologists identified the solitary and migratory phases of Old World locusts as being entirely different species. The initial theory of the Rocky Mountain locust's disappearance was that the extinction was an illusion. The solitary phase was still extant, but a change in the ecological conditions simply prevented the appearance of the well-known gregarious form. Entomologists proposed various candidates for the solitary form, but despite heroic efforts to force a transformation, nobody could reincarnate the Rocky Mountain locust. In more recent times, analysis of the waxes comprising the insect's cuticle, along with studies of DNA extracted from locust specimens preserved in glacial ice, have confirmed that the Rocky Mountain locust was a true species, not simply the migratory form of an extant grasshopper. So what could possibly account for the extinction of a species that once blanketed 2/3 of the United States? For half a century, scientists proposed and refuted a series of explanations. An acclaimed entomologist argued that a changing climate at the end of the so-called Little Ice Age in the late 1800s doomed the locust. However, others undermined this theory by pointing out that the thermal trend was too gradual to account for the extinction and, if anything, the warmer and drier conditions that began to prevail should have favored the locust. A clever ecologist argued that the locust depended on bison to break up the sod and overgraze the grasslands to create favorable habitat. So, the loss of the bison meant that the insects were destined to decline. But critics pointed out that the Rocky Mountain locust preferred to lay its eggs in compact soils, and moreover, bison would have competed with the insects for vegetation. Yet another scientist made the case that locusts depended on landscape alterations provided by the Native Americans, who used fire to expand and maintain vast swaths of prairie. While forests did begin to encroach on grasslands following the extirpation of indigenous people, the scope and rate of change were far less than necessary to account for the disappearance of the insect. There seemed to be no ecological change of a sufficiently large scale to account for the locust's demise. And therein lay the key. See, during outbreaks, the Rocky Mountain locust occupied nearly 2 million square miles. But the solution to its extinction was not the species ecology at the height of its flourishing. Instead, the answer lay in understanding the creature during the time of its most restricted distribution. As with other locusts, in most years, the climatic factors necessary to elicit an outbreak did not develop, and the populations eked out a living in highly restricted habitats where they could find adequate food for their bellies and suitable soil for their eggs. The fertile montane river valleys of the West were the locust's sanctuary and its Achilles heel. During its recession periods, it was constricted to an area of 1,000 square miles. The entire species would have comfortably fit in a circle of land less than 20 miles in diameter. Of course, the river valleys were not laid out in a neat circle, and nor were the locusts uniformly distributed. However, no matter how we parse out the locusts and their habitats, the implication is the same. This species was regularly squeezed into a tight ecological bottleneck. When the outbreak of the 1870s collapsed, the locust became concentrated in these mountain valleys, and its timing could not have been worse. For these were precisely the lands that the pioneers sought to convert to agricultural production. Farming the river valleys of the Rockies became enormously profitable thanks to the burgeoning demand for food by the mining industries. Growing grain, not finding gold, held the key to sure wealth. And so it was that the locust sanctuaries were decimated. The soils where the insect concentrated its eggs were plowed and harrowed. To add insult to injury, large tracts of land were planted to alfalfa, one of the very few plants that the locust could not abide. And to sustain this thirsty crop, the farmers flooded the fields, drowning untold numbers of locust eggs. While upstream, beavers were eliminated along with their troublesome dams so that spring floods washed away both eggs and hatchlings. To make matters still worse, cattle and sheep were introduced into riparian areas, where their grazing widened the waterways, further exposing the insects to inundation, not to mention the destruction of egg beds through the trampling of the livestock. It sounds incredible that the most spectacular success in the history of economic entomology, that is, the only complete elimination of an agricultural pest species, was the consequence of an unwitting bunch of frontier farmers armed with cows and plows. But could the pioneers have destroyed every egg bed, every population of nymphs, every gathering of adults in the mountain valleys? No, but they didn't need to in order to extinguish the Rocky Mountain locust, because the insects formed what we now know to be a metapopulation. Pockets of locusts were linked by local movements into a network. When a natural event caused the disappearance of the insect in one valley, that habitat would soon be recolonized from a nearby population, sustaining the metapopulation. The farmers accelerated this background rate of loss to such an extent that they wiped out enough of the local populations so that recolonization could not keep up. And so the entire network collapsed. The species winked out of existence without our ever having to destroy every isolated pocket of locusts, let alone every individual. Consider a modern parallel, the monarch butterfly. Much like the locust in the late 1800s, this migratory species is poised for extinction. How could a butterfly that fills roadsides and fields from Texas to Maine be in jeopardy? Well, at the end of each summer, this species packs itself into a few pockets of fir forest in the mountains above Mexico City. Imagine having 30 or 40,000 monarchs in an area the size of your living room. Loosed on these sanctuaries, a logging crew could inadvertently put an end to this magnificent butterfly in a matter of a few weeks. Indeed, there is much to learn in modern times from the lessons of the Rocky Mountain locust. We now find ourselves in a new frontier, an era of shifting conceptual landscapes and moral perils, a time of CEOs, scientists, and conservationists, a time of grasping the consequences of our past, a time in which we wonder if our socioeconomic values are on a collision course with the constraints of the natural world, and what this will mean for us and other living beings. Ecosystems are often presented as richly integrated webs of living beings. This provocative conceptualization reflects elements of the interdependencies between pollinators and flowering plants, fungi and algae in the form of lichens, and various other well-established mutualisms. And so, surely there is reason to believe that the loss of such a keystone species as the Rocky Mountain locust would have had noticeable ripple effects throughout Western ecosystems. However, as far as we know, the extinction of this dominant life form, along with the extirpation of bison, wolves, beaver, and other creatures, had few dramatic effects on the functioning of the vast shrublands and grasslands of the newly forming West. The conservationists' argument that we must save species because we need their ecosystem services is feeble. The contention seems to suggest that the role of other species is somehow to assure our well-being and survival, or that most species actually do so. In the eastern United States, the passenger pigeon and the American chestnut disappeared with barely a whimper. At some point, it is conceivable that we might so simplify ecosystems that we could no longer extract resources and services from them. But socioeconomic rationales for conservation, including all those yet to be discovered cures for our ails, seem a bit disingenuous. These arguments are similar to speculations about all the financial rewards, official honors, and social recognitions that could accrue from returning a lost wallet. Now, the ultimate and perhaps only compelling reason to return a wallet is that it is the right thing to do. Perhaps this also holds for why we ought to look after our fellow inhabitants of the earth. My applied entomology textbook suggests that insect outbreaks are evidence of a disturbed or out of balance ecosystem. As with a well-behaved child or a good worker, species should refrain from extreme outbursts. This Victorian era interpretation of the ideal emotional state may well be a cultural legacy of Darwinian uniformitarianism that emerged as a reaction to the church's reliance on catastrophes to explain the geological history of the earth. Whatever the origin of this notion, and perhaps it traces all the way back to the Greek ideal of the golden mean, the virtue of constancy has lived on in our perception that an outbreak or crash of a population is an unnatural aberration, an indication of a troubled species. But the leitmotif of the Rocky Mountain locust was its phenomenal flights of reproductive fancy, with manic swarms sweeping over the plains only to subsequently collapse into pockets of exhausted survivors. Evidence of this pattern was embedded in the annual layers of Knife Point Glacier, which revealed a pattern of locust outbreaks extending centuries prior to European alterations of the Western landscape. Erratic, even explosive population dynamics do not require anthropogenic disturbance, nor do they necessarily reflect dysfunctionality. It is true that people, species, and ecosystems can manifest extreme dynamics during times of trouble, but all too often, we are alarmed by nonconformity, not because of concern for another being, but because of our own self-interest in having a predictable world, our socio-political intolerance of radicalism, our economic objective of slow but steady growth, and our Protestant ideal of moderation. Sometimes the outburst of joy from a child, the cry of anguish from a friend, or the outpouring of life by a species does not need to be fixed, controlled, or managed, but understood, accepted, and honored. Upon returning from our first expedition to the glaciers of the Rocky Mountains, my colleagues and I submitted a paper portraying what we had found at Grasshopper Glacier north of Cook City, Montana. We described the location of deposits, the types of insect parts we had extracted, the radiocarbon dating, and the analysis that led us to believe that we had recovered the remains of the Rocky Mountain locust. As the first report of such a study in nearly 50 years, we hoped the manuscript would be well received. It was rejected. The editor of Environmental Entomology explained that the study did not constitute a controlled experiment. Where were we supposed to find a controlled glacier? And what experiment could we have done if we had located such a resource? My appeal to the editorial board, the only time I had the guts to take such a step, was denied with the incisive summary, and I have kept this letter, quote, "You have mistaken natural history for science." It seems that statistical design and controlled experimentation defined science for the research community. This suggested that initiatives such as the Human Genome Project decidedly lacking a clear hypothesis, and NASA's deep space probes, utterly devoid of replication, are not science. It was as if nothing of value was left to describe in the natural world, a remarkable position for entomology, a field in which 90% of its fundamental units of study, that is, insect species, are unknown. Even more disturbing was the notion that science required manipulation of the natural world rather than patient observation or thoughtful description. The Rocky Mountain locust is gone, and no experiment can retrace the events that led to its demise, explain the role it played in Western ecosystems, or reveal what other species may have perished along with it. Its tale will be told, if at all, to those willing to listen rather than to those demanding answers. Although it required nearly 75 years, we finally resolved that the Rocky Mountain locust was a true species. But a greater question remains. The debate itself raises the question of what constitutes a species and reveals our philosophical biases. We usually conceive of the natural world in terms of material things. For example, a species is a bunch of individuals with the capacity to successfully interbreed. But this presumes the metaphysical truth of materialism, that to be real is to be made of matter. Ecology, however, is beginning to shift its focus with tentative explorations of what the world would look like if process rather than matter was the basis for reality. For the Rocky Mountain locust, it was the swarms, or more precisely, the process of swarming, that constituted this remarkable species. This perception of the locust's essence is counter to the material terms in which we usually conceive of the world. We normally define a species as this set of individuals with some shared qualities, typically this capacity to successfully interbreed. This orthodox definition equates being real with being made of matter. In this light, a species is the sum total of its members, the Rocky Mountain locust being comprised of trillions of bodies that washed over the continent like a living tsunami. Ah, a tsunami. You see, a wave is not water. Our sense that a wave is a mound of moving water is an illusion. The wave is the energy coursing through the fluid, while the fluid is merely the observable evidence of that which surges within. A wave is no more the water than wind is trembling aspen leaves. In this light, we might seriously doubt whether the monarch butterfly can be conserved within a refuge, a zoological garden, a vial of DNA, or a sequence of the letters A, T, C, and G. If this species could not cluster against the chill rains of winter and sprawl into the milkweed patches of summer, what would we have conserved? What if a thing is what it does? What if we defined a species in terms of its life processes? In this light, the Rocky Mountain locust was an immense aperiodic energy flow that linked living systems across a continent. It died well before the last corporeal manifestation disappeared. Perhaps somewhere in the vastness of the Rocky Mountains, a remnant population of the locust clings to life within a fragment of habitat. But they would be no more their original species than a colony of monarch butterflies flitting futilely within a glass house. Unless the locust could once again blacken the skies, it would, in fact, be something else. Perhaps a Rocky Mountain grasshopper, but not the Rocky Mountain locust. As you well know, 2002 passed without any recognition of its being the centennial of the material demise of the Rocky Mountain locust. There was neither mourning nor celebration of this biologically momentous event. Perhaps our willingness to overlook the passing of this species was a matter of blissful ignorance. For if we understood the story of its extinction, the implications for our environmental complacency would be most disturbing. The simplest and most unambiguous lesson that we can learn from the Rocky Mountain locust is that numerical abundance does not assure future survival. Having exceeded 7 billion people, we need only look back at the voracious swarms of the Rocky Mountain locust that blackened the skies of North America to realize that our future as a species is no brighter for our quantity. Being an abundant, prolificous, and highly mobile species is no guarantee against extinction. There does, however, seem to be a major difference between our condition and that of the Rocky Mountain locust. This species had become wholly reliant on a place, requiring it to sacrifice other options and accept the risks of being profoundly and deeply linked to a landscape. For the locust, the fertile valleys of the West were its sanctuary, a habitat where it could always find what it needed and persist in the face of adversity. The complex and intimate connections between the land and native species are difficult, perhaps impossible, to express in objective scientific terms. But sacred places are central to the well-being of many creatures. Even with all the right conditions of temperature, light, humidity, and diet, animals often languish in zoos. They are unable to express what is missing, and perhaps we would be unable to understand, unless we too had experienced the soul-wrenching loss of being forced from a farm or ranch that had been in the family for generations, or being driven from a homeland that defined our traditions, our stories, our hopes. We are reluctant to call the habitats of other species sacred because their sacrifices are not volitional and their seeking of sanctuary is unconscious. But we did not design the World Trade Center to collapse in on itself. We did not plan for the buck and rail fence east of Laramie to be the site where Matthew Shepard would be sacrificed to our fear of differences. And we did not intend the basements and attics of the houses along the Underground Railroad to be sanctuaries for runaway slaves. As self-aware animals, we do what we can to protect our sacred spaces. And perhaps we should honor the needs of other creatures for their hallowed places. Despite my deep understanding that the Rocky Mountain locust is gone as a species, I've searched for remnant populations in the irrational hope of meeting a few survivors. They may no longer be able to transform into the migratory phase, but I imagine that being in the midst of this noble creature might well transform me, much like being in the presence of a wise teacher. My surveys of grasshoppers in the greater Yellowstone ecosystem have yet to yield a specimen of this long-lost creature. But even if I found a pocket of habitat still harboring the locust, regulatory officials might well advocate their destruction, as the potential for a return to the swarms of the 1800s would be plausible. Even the vaunted Endangered Species Act exempts pests from protection. So perhaps this remnant population would be accorded the same status as the last vial of smallpox. I like to imagine that, in an ironic peak, economic entomologists would point out that a population of the Rocky Mountain locust that had not bothered us for a century could hardly be termed a pest, as their numbers had not attained outbreak levels. From the environmental camp, a few voices might call for protecting these insects as important components of native ecosystems that are struggling to sustain biotic integrity. There might be some appeals to the Rocky Mountain locust's capacity to serve as a reminder that we must share this world with other species, even those that we have not tamed or controlled. And a few advocates probably would invoke the powerful place of this species in the story of the West and the folklore of America. But in the end, would our decision be any different from that being made by the people of Amazonia, or that which would have been made had the early pioneers realized that they had reduced their nemesis to a single locale? If we struggle so mightily with whether we should save the last bits of old growth forest and the few untrammeled tracts of the Arctic, what hope would a locust have? What have we really learned about ourselves and our place in the natural world? Well, thank you everyone for staying with it. And I guess I'll stop this sharing. And if there are any comments or questions or objections or whatever you have, I'd be happy to entertain those.
That was absolutely wonderful. Thank you so much. I really enjoyed it. I have a question. Everyone else, you can take yourself off mute to ask questions. But I guess my first question is, what other research did you do for that book, and how did you do the research?
Well, a lot of it was getting into historical documents, reading Riley's reports, reading USDA reports, looking at historic maps, trying to look at the distribution of agriculture and agricultural various crops in the late 1800s versus the distribution of locusts. So much of it was getting into the primary sources and trying to see what I could get out of those. There's chapters in the book also about the role of the locust and sort of the American culture at that time. A lot about C.V. Riley, so I did lots of reading about Riley and his gang. They played an instrumental role in coming up with various accounts of the Rocky Mountain locust. But I mean, everything in American history kind of was involved at the time. Economics, religion played this huge role in terms of interpreting these locusts through the lens of an angry god. Of course, politics was involved. I mean, this was really just about the first time that hardworking, people of the earth, pioneers, had had been facing starvation, decimation through no fault of their own. I mean, at that time, the notion was, and it still is, that people are in poverty because they're lazy or they have some character flaw. But this made clear that people could be in desperate straits through no fault of their own just by a happenstance of a natural phenomenon. So it really lay the foundation for how we interpret natural disasters continuing to today. That there is a role of government, and that when these things happen at such a scale, local and state governments cannot possibly deal with disasters such as Hurricane Ian.
Mm.
I have a question about the African locust. Is their biology similar to that of the Rocky Mountain, as far as where they, lay their eggs and?
To a certain extent, the desert locust lays its eggs. They're not quite as habitat specific as the Rocky Mountain locust. Locusta migratoria, particularly in Asia, would be a closer analog because they lay their eggs in these along these lake shores where there's lots of phragmites, and so they're much more concentrated than the desert locust is. So there are locusts that are more dispersed in these periods of between outbreaks, and there are those more like the Rocky Mountain locusts that are much more highly concentrated.
Just a comment that seems to me that almost every lawnmower has a grasshopper, but in these days of inflation, very few have a locust.
Oh,
Yeah.
That's
I
our
have
resident penologist.
I have one more question. Hello? Yeah, I have one more question. Okay, the monarch butterfly is in danger here, but it's spread to the old world, like Australia,
Right.
Parts of Africa, because its host tropical milkweed, has spread there, and also there's other species of milkweeds there. So its numbers increasing there, or it's?
That's a good question. Yeah, I mean, the analogy is imperfect because there's obviously the Western population that moves up and down the Western coast. The Eastern population that sort of floods Middle America up into the Northeast. That population all aggregates down in Mexico. And you're right, the monarch butterfly does exist on these other continents. So it wouldn't be a true extinction of the species if we were to wipe out the overwintering grounds in Mexico, although an enormous population and a very special population, and one that, as I understand it, probably does not genetically interact with the Western population, which again leads us to wonder, well, are these separate species if there's no gene flow? And well, you guys all know those sorts of troubles. And so whether or not it's a separate species, it certainly could disappear. And I guess the point of that story was there are insects and other species that become highly concentrated in these ecological bottlenecks. And quite remarkably, a species that maybe have an enormous distribution at some times may be highly vulnerable at other times. I guess that was the lesson that I was trying to develop there.
Hi, this is Steve. A question popped into my mind several times through your talk that may not be related to your point, but it seems to me that if I had been a pioneer at the time, that I would have asked myself, what would I have been able to take this resource that killed all of my food and eat them themselves, dry them out, store them, and possibly get through the winter? Did this come up in your research?
It absolutely did. Charles Valentine Riley latched onto that pretty quickly and thought, well, if it eats your crops, maybe you should eat it. And he worked with a chef in St. Louis to develop recipes for the Rocky Mountain locust. And so he was a strong advocate of eating the locusts as a sort of way to make your way through a period of desperation. And so there are recipes produced, and he has notes in some of his reports about having served these at various functions, I guess with and without informing the guests of what they were eating. So yes, you're really onto something, and Riley was onto it as well. Of course, at that time and continuing in today, the notion of, coming from, Western European tradition is that eating insects is an act of desperation, right? And that, maybe it's about as repulsive as eating other pioneers if you run out of food. So the idea was there, the protein source was there, the lipids were there, but the cultural obstacles really couldn't be overcome, and that was the problem. There is good evidence that some Native American tribes relied very heavily on both Mormon crickets and Rocky Mountain locusts. There's a site in Utah near the Great Salt Lake where it appears that a swarm or swarms of locusts would descend into the Great Salt Lake at certain times, wash up on shore, and then bake in the sun. And so the Native Americans would come along and collect basketfuls of locust jerky, salted and sun-dried. And it probably was far, far more valuable in terms of calories than chasing bison and other vertebrates across the Great Plains. And so there really was an obstacle, sort of for those of a European disposition, not so much a Native American disposition.
I'd like to ask a quick succession of about 3 questions, if I might.
Yes, yes, no.
And I'm going to take off where you left off. I don't know if you can see this, but this is a bag of Metamorphosed devastator, whose habits flirt with the Rocky Mountain locust on a smaller scale, where for several square miles, we get these giant outbreaks in montane meadows of Southern California. And so, yes, I actually can fry them up in butter and add a little salt. And as long as you take the wings off, because the wings are all chitin, everything else goes great with chocolate chip cookies. So that brings me to my first quick question. When you did the DNA of these carcasses you've extracted from the ice, has anyone done any phylogeny with the Specios melanopus in general to find out who it fits close to, and might it be devastator?
Yeah, Bill Chapko up in Canada. I'm not a molecular biologist or a molecular geneticist, so that work was done by me climbing the mountains, which was the fun part, and then him going to the lab and doing a dull part. At least that's my opinion. And yeah, he did a phylogeny, and I think there's some scientists in Australia who are following up on that. And if I remember right, one of the suspicions was Melanopus sanguinipes, one was devastator, but I think the tightest relative may have been Melanopus borealis.
Oh, that's interesting.
Yeah, so montane might be the key there.
Yeah. All right. So my next question, it sounded, you were almost, I thought I heard you saying later in your talk that not only did you just find these things exhumed from crevasses, but you found a stratigraphy where there might have been multiple episodes of datable outbreaks in the glacial stratigraphy. And my question was sort of, were these outbreaks rare once every few decades, over centuries, or was this sort of a really common event? Because it's something that doesn't sound to me like this was a common thing. It was big deal at the late 1800s.
Right, so it's a great question. So in the upper portion of the glacier, where it flattens out, the layers get all jumbled together, but in the upper portion of the glacier, you could walk up that section. It was like walking up the edge of a stack of plates. And so each of the annual deposition layers, the edge of that deposition layer was exposed. And so it was just like this series of stripes as each year's dust and whatnot would blow onto the glacier, get compressed. And so you could basically walk backward through time. And we sampled that sort of edge of those stacked plates, went back, I think it was almost 400 years. And then we looked for evidence of locusts. Now remember, this is sort of like taking a biopsy, right? We're looking at just one glacier, right? So we're not getting the whole Western phenomenon here. But when we looked at that, we determined which layers had locusts. And one of the things we're looking for was periodicity, some sort of regularity, in mathematical regularity in terms of the outbreaks, and we found no evidence of that.
I'm gonna check the mail.
What was that? Which wasn't really surprising because weather records tend not to be highly cyclical either. But what we found was that the time between outbreaks, and this is sort of supported at least for maybe 1800 to 1890 in the records that Riley reveals, outbreaks would, at any given location, would happen every, say, 4 to 12 or 15 years. And so it could be as short as 4 years between outbreaks, but then you could go as long as a decade before the next one. So they were irregular, and you might think of, on average, it might be something like 8 years, but, averages are very, as I tell students, right? The average person has one ovary and one testicle, and that's what we know about averages, right? So you probably ought not to trust averages when you have a lot of variation. And so, think about, 4 to 12 or 15 years between outbreaks at any given location.
So I'll spare you a couple more questions, but my last one, and you may not want to answer it, but I understand the issues with ecologists in the entomology journals. And I'm wondering if you'd be willing to share with us who the editor was that rejected that.
Oh, that's a good.
And when it was, when you submitted this.
Oh man, now you're asking a hard question. I honestly don't know the editor, but I would be happy to out the bastard if I did.
It wasn't Rick Reddick, was it?
No.
Okay.
I know Rick, and that would have been more recent. And if it had been him, I would have been happy to reveal it.
Okay.
No,
That's
actually, Rick Reddick was a graduate student at CSU when I was at the unit. Well, I've been at the University of Wyoming, so I knew him through that connection. So I would have given him a terribly hard time. Now this would have been in sort of the early mid 1990, maybe 93,
okay.
94. Yeah.
Right. So he was my major professor for my graduate studies, and we were like oil and water. So he's like an ecologist and not an entomologist and all that. So anyway, interesting stuff. And I feel that your ideas of the metapopulations and the sort of ecological impacts that settlement brought, that I don't know how much really good evidence you have of that. It seems like a good working hypothesis, but there's no way to, nobody ever did any studies on the ecology of it while it was still functioning.
Yeah. I mean, in philosophy of science, that's referred to, and I like this term, it's the inference to the best explanation. Yeah, and we've worked hard to dig up historical records. My brother, who's a mathematical biologist, and I did a little bit of mathematical modeling about distances and some real wild guess, wide-eyed seat of the pants assumptions, and the model was consistent with this explanation. But ultimately, it's a story that it's a story we'll have to tell based on the best available evidence, and I don't think the evidence is going to get much better. As a matter of fact, the evidence is getting worse. Those glaciers are disappearing at a phenomenal rate. Let me just, I'm going to pop up this screen share really quickly here. On this slide, let me find that slide. It'll take just a second. That's not it. There, this slide. In the upper left is a glacier called Grasshopper Glacier in 1952, I believe. In the bottom right is the exact same glacier. You can see that little outcropping of right down on the outcropping of rock on the left side of the picture, and that mountain peak. And so this is just about the same angle, and that's the glacier in the mid 90s. So that's glacial recession in 40 years. And glacial recession at Knife Point Glacier is phenomenal. There are now heaps of rotting locusts lining both sides of that glacier. And, you know, I've tried various efforts to convince various agencies to fund, you know, the collection of material from that, but it's an absolute tragedy. Of course, climate change is a tragedy for the loss of water, but there was a fantastic historic record that's just washing away in terms of the history of entomology as well.
We could extract the DNA and soon it'll be possible to reconstruct those chromosomes and we could resurrect this grasshopper.
There you go. And we'll reintroduce the locust and the mammoth at the same time.
Exactly.
And everything will be good again.
Back on the subject of the edibility of these critters, I've read that the Native Americans in California managed the meadows with fire and dug a pit and then drove grasshoppers into that pit. And that was a substantial food resource for those tribes. And I've also noticed in some Mexican restaurants, particularly Oaxacan restaurants, that they have a dish of dried grasshoppers sort of as finger food instead of pretzels or popcorn. So
Yeah, they are. I think they're really quite tasty. I mean, there's the story that when a Native American leader was brought to Washington, D.C. to negotiate a treaty that we inevitably broke, but he was in Washington, D.C., a Plains Indian. They served him shrimp, of all things, and he rather enjoyed them and commented on how similar they were to grasshoppers. And which makes sense. An arthropod is an arthropod to a certain extent. And I think they do have a mild seafood flavor. You know, there's also a big section of my book in which I go through all of the incredible methods that Riley and his colleagues proposed for farmers to control these locusts. And you know, you were talking about the Native Americans digging the ditches. That was a method that Riley advocated. As a matter of fact, they went through and systematically determined what the optimal width and depth of the ditch was so that you'd get the most locusts for the least amount of work. That's a sort of Yankee ingenuity applied to a Native American practice, I guess. So they had these fantastic devices, machines, vacuums and crushers and scoopers, all which were horse-drawn over the infested grasslands to try to suck up, destroy, burn, or whatever, as many locusts as possible. There was a time in which there was a bounty. State and county governments put a bounty on every bushel of locust eggs and locust nymphs that could be brought to the county courthouse. And so my favorite was dynamite, which probably didn't do anything, but I bet it felt great to blow up the little bastards.
there are other species of grasshopper that at times become very common. I don't think you mentioned much about whether any of those species are in peril, or if there's a difference in their ecology that accounts for the fact that they're not in peril, even though they may have outbreaks of great abundance.
Right, good question.
Do you have any thoughts about that?
Well, yeah, I do. The reason why they're probably, well, one neat thing about grasshoppers is that all the species in North America are native. So we don't have any invasive exotic grasshoppers. So yay for the grasshoppers. And you're right, there are grasshoppers that reach very high densities. You know, I've been in outbreaks in concentrated areas where there's 100, 150 grasshoppers per square yard. So they do reach enormous densities. And there are species that are relatively rare, but it doesn't appear that any of them, at least at this time, is endangered. And it probably is because they don't have, as the Rocky Mountain locust did, this highly hyper-specialized, at least spatially. Some of them are pretty specialized in terms of their diet. For instance, Hesperotetex viridis feeds almost exclusively on snakeweed. But snakeweed is widely distributed, and even though there's efforts to eliminate snakeweed, it hasn't put that species in jeopardy. So given the geographic distribution, given that many, if not all species have relatively wider diet breadths than a number of other species, I think those work in favor of grass. Well, and the other thing that works in their favor is, as much as we've altered the Western landscape, there are still vast areas of grasslands that are largely intact. A lot of them, are, if anything, the biggest problem is invasive plants. But there's still, nonetheless, pretty vast areas of the West, all the way from New Mexico, up through the Rockies, where the habitat is more or less as it would have been, including montane habitats. Now, I don't know. I certainly don't know the ecology very well of the eastern species, where the conversion of land is more intense. But I'm not aware of any species in the eastern United States, at least of the acrididae, that are endangered, or even presumably at risk.
Given what
I
I
had
know
a
about
question.
our butterflies, it's hard to imagine that would be true, but I'm so ignorant when it comes to the Orthoptera that, that's just my imagination having its way with no factual basis. But it just seems that there would be local species or species that were tied to particular food plants.
Well,
There's a federally endangered Trimeratropus in Santa Cruz County.
right. So,
I have a question.
one of the explanations might be that we've not, well, as little effort has been put into, the systematics of insects in general, right? At least the butterflies are better known than the grasshoppers are. And to be quite frank, I wouldn't be surprised if there are not some highly localized, highly specialized species that either are at the brink of extinction or have been lost. I think our ignorance is fairly deep in terms of the Orthoptera. And so part of the reason why we don't think anything is endangered might be because we don't know enough to have isolated and identified these highly localized, specialized species.
It seems to me that Jerusalem crickets can be very local, and perhaps on the brink. And I know certainly after rains, when I used to walk in my neighborhood in Pasadena, I would see Jerusalem crickets in the gutter. I don't see that anymore. Of course, we don't have rain nearly as often, but I think the Jerusalem crickets in town or near town have become quite rare. Used to be relatively common.
I have a question.
Does the moment? Oh,
I have a
Go ahead.
question. Is it possible that you're missing another cause of the extinction, like a disease or a virus that might have infested the entire population?
That is possible. It would have to have been presumably a newly introduced disease or a newly introduced fungus or pathogen, because the Rocky Mountain locust had been living under these natural conditions for centuries. A colleague of mine in glaciology actually did an ice core and pulled up a leg that was carbon dated to 800 years before the present. So they've been here a long time. And so, if there was a disease outbreak, and we know from Riley's work that there was a number of mites that would reach some enormous levels at certain times, and would decimate at least local populations of the Rocky Mountain locust. So I think it would have to have been a new introduction. We looked for, when we got the locust out of Knife Point Glacier, one of the things we looked for was any indication that population, which the ones that were coming up were 400 years old. So we compared those to some to some that were perhaps from the late 1800s, late 1870s. And we didn't see any indication of a genetic bottleneck. It doesn't look like, it looks like whatever eliminated them took them out in a period of 10 to 15 years. And a pathogen could do that, but I don't know of any orthopteran pathogen. And of course, there's a number of viruses and fungi that infest, the acridiids, but I don't know of anything that could take them from such enormous numbers to zero in a matter of perhaps 20 years. So we did look for circumstantial evidence, and we didn't find it. But again, that's sort of the absence of evidence is not evidence of absence problem.
Thanks.
Does the Mormon cricket ever have large outbreaks?
Oh, it sure does. Yeah, Mormon cricket still has very, very impressive outbreaks. Of course, it doesn't have wings, so it's not going to get very far, but it sure does move out of the mountains down into the croplands in Utah, western Wyoming, northwestern Colorado, Idaho, sometimes in just absolutely staggering numbers. And it's interesting too, because it has this kind of this phase polymorphism, right? So when they're up in the meadows at low densities, they're green with sort of a little chocolatey stripes, and they become coffee dark brown when they reach these high densities. So they go through a definite coloration change, and they march in these bands. So they have this kind of locust-like quality to them, which is really an interesting phenomenon. And so, yeah, they still exist. They're still doing very well. There's, certainly there's fantastic reports of Mormon crickets as well as Rocky Mountain locusts devastating the farms of the Great Salt Lake Valley when Brigham Young was settling his people there. And there's some parts in the book where I talk about the ways in which the locusts at that time were being interpreted by the Mormons as evidence as Brigham Young was using them as evidence of his people having disobeyed the rules, the laws. And so the Mormon crickets, as a matter of fact, if you want, I can send a link that then you can pass around. Among the things I've done is I've written and produced a 1-hour opera on the Rocky Mountain locust. And I have a 15-minute opera on the Mormon cricket. And so I've written the libretto for those and worked and collaborated with an opera company as well as a composer. So you can get this whole story in opera form and a 1-hour chamber opera as well.
So you've worked with composing locusts and decomposing locusts.
Thank you. Thank you. Very good.
Good. Hi, Jeff. I was going to ask, the Dust Bowl years had some very significant grasshopper outbreaks, but that was post Rocky Mountain locust, wasn't it? So what were the grasshoppers involved in those?
From all that I've read, I wasn't around then. It appears to have been Metamorphosed sanguinipes.
Okay.
Now, again, we talk about in biology, we talk about there being grasshoppers and locusts, and as if these are discrete, right? And there really is, this life form has a continuum, which actually everything in biology has a continuum, right? And so, the Metamorphosed sanguinipes is called, the common name is the lesser migratory grasshopper, because it does form swarms, not as tightly packed as a good locust, and it also doesn't seem to form these bands of nymphs. And so I would call it a very weak locust, but there's not really a sharp line between this is a locust and this is a grasshopper. And so, something like the 30s with Metamorphosed sanguinipes, it did form swarms and looked locust-like, which is, I think, the reason why that was the first candidate for once the geneticists got hold of these creatures and said, aha, that's the old Rocky Mountain locust. It's just not up to its old tricks quite as much. But that turns out not to have been the case. Yeah. So yeah, that was and a lot of, at that time, there was a lot of discussion that the Rocky Mountain locust was back. Because you're only looking at less than 50 years from the last of the gigantic outbreaks to that time. So the memories were still fresh.
Quick, aren't there museum specimens of intact locusts that were collected in the 1870s by entomologists sitting in the Smithsonian that you could compare with sanguinipes and devastator and things?
Yes, yeah. And actually, what's really surprising, but maybe not so surprising, is that there's only, I used to have the number and I could go back and look it up. There's something like 200 specimens, museum specimens in total of the Rocky Mountain locust. Why collect something that's super abundant, right? And it disappeared so quickly that I guess nobody thought, wow, we should collect these, because everybody thought it was coming back. I think the biggest collection is at the Philadelphia Academy with Dan Ott. And so, yes, we've been allowed to do some. I mean, when we were doing before we got into the genetics, a colleague who was really into cuticular hydrocarbons looked at, we were allowed to extract some of the cuticular hydrocarbon of those specimens, museum specimens. And, if you look at, if you look at the classic structures, all right, the internal genitalia of the male, the epiphalus and the cingula, it looked, that's why the early taxonomists said, no, this is a different species. But of course, those differences can be a little bit subtle. There can be variation. And that's why, in the modern age, you doubt the wisdom of the traditional taxonomists, and you whip some genetics and biochemistry on them and find out that maybe the taxonomists knew what the hell they were doing after all. Yeah, so getting permission for destructive, and it is destructive if you're gonna get into the internal genitalia of the males, which is sort of the definitive character. So understandably, curators are a little bit hesitant, given how surprisingly sparse the number of specimens is, to allow many of them to be used in that way. The other thing we found out, though, is that the mandibles of the closely related species, or what we believe the closely related species, the mandibular morphology is fairly distinctive as well. And the mandibles are the part of the specimen that preserves almost apparently forever in a glacier. So we were at some glaciers, one near the Beartooths, where we could find nothing, no evidence, even though there were reports from the early 1930s. We couldn't find any whole bodies, but we did manage to find mandibles. And so then we ended up doing a whole rather enjoyable study of mandibular anatomy. And yeah, it looks like you could, I guess the taxonomists, are still going to go with the genitalia, but the mandibles were pretty distinct between that species group.
Sort of like Darwin's finches.
There you go. Yes, there you go.
You can count on there being selective pressures driving that and some functional differences in those species.
Yeah, yes.
Well, I think it's time for me to say goodnight, but thank you for a very interesting presentation and discussion afterwards. Much appreciated.
Well, thank you, and thank you for indulging. Since I've drifted, if you will. I never feel like I've given up entomology or science. Somebody said, "Gee, was it hard to give up being a scientist?" And I said, "No. Entomology is like the mafia. You never really get to leave." And so I don't feel like I ever left, but I've really enjoyed taking entomology, the raw science, and then transforming it into stories and books and essays for the public. And one of the first pieces I wrote was in Orion magazine, and I sat down with the editor. We were at a workshop, and he looked at the piece and he said, "Oh, thank God it's not another essay on whales or wolves." He said, "Maybe out there somewhere another essay needs to be written about whales and wolves, but insects are such fantastic raw material." And so I love the element of storytelling And I know some of my metaphors and analogy and perhaps quasi-poetic language might stretch the credibility of a hardcore scientist. But so thank you for indulging my creative proclivities.
Quite a pleasure. Thank you.
Well,
Thank you.
the point you made about the human race at over 7 billion people, we may be more fragile than we think. And that's a very valid point. We could all disappear. I mean, someone drops that file of smallpox in a lab, and we could all find ourselves in deep trouble very quickly. So it's a very valid point. I'd like to thank you for the presentation. Very enjoyable. If you have another book coming out anytime soon, let us know. We'll invite you again. And this will be available probably until the next meeting as a recording. And if you want to refer anyone to it, you're welcome to. And we appreciate your talk.
Well, let me just tell you, I do have a book and a rather spiffy presentation on entomological warfare, the use of insects as weapons of war.
Oh,
So that's even darker than the extinction of a species. If you want to hear about the horrible things we've done to each other with insects sometime.
love to. Strangely.
I'd like to read the excerpt or the abstract of that.
They're
That's
very interesting.
how do you
It's
do
called
that?
Six-Legged Soldiers.
And the US engaged as well with the Colorado potato beetle against the Germans, I think.
Yes, we were accused. Yeah, we probably did. It was the Japanese who really led the way with their Unit 731. The Japanese, just the short version, Japanese killed more Chinese with plague-infected fleas and
Oh.
cholera-coated flies than we killed in Hiroshima
Wow.
and Nagasaki put together. So biological and entomological warfare was more deadly in World War II than which isn't a justification, right, for dropping atomic bombs, but it does suggest that biological weapons can be even more effective.
Please send us your links to those operas. I gotta see
Yes.
that.
Yes, definitely.
Will do.
Thanks a lot.
All right. Good night now.
Thank you.